How's it going, guys? Matt here. Sorry, I don't have my camera set up. I'm at a new place and don't really have that arranged quite right. Today we're going to look at the decorator pattern in programming. And to start out, we're just going to look at the wiki because I'm not trying to reinvent the wheel here. This is a pretty well-known pattern at this point. But I want to talk about its usage and in general when you should be using it and basically what the professionals say on the topic. So we want to be sure to cover this, and we're going to start getting into other ones too, like flyweight, and I'll talk about those briefly but more later. So with that intro out of the way, let's take a look at what the decorator is for. Essentially, it is an interfacing idea. You can see here in this intent section, it ultimately has a component with an operation. This would be the interface, this top end one, I think here anyway. But what we're seeing here is some inheritance, mainly this concrete component. Now this is one that is something you can instantiate. This one up here is an interface. They don't really make that clear in this diagram, but interface, this one implements the interface, and we'll show that in code later. And then what you have is decorators. Now decorators also use this concrete one because they do it in sort of a cascading like fashion of adding stuff. It's a way to add components and a way to have an interface where you can decide which components you want to add to do different things. There's quite a few examples here and a lot of additional reading you can do on the subject if it isn't clear to you after this video, but hopefully I can wrap that up rather quickly for you. Here are the common use cases as stated by the wiki. Well, basically it's when you kind of want to add, remove things on demand, like it's commonly used in UI applications. And if you're doing it in bulk, you can put a state design pattern also behind it. Flyweight objects, a lot of times these components will be things that are exactly the same. And if you're using multiple of them, you want to make them a flyweight, but essentially means you only want one instantiation of an object, and everything else, if they're using the exact same object, well, type of object, you just reference it. We'll talk more about that later. There are some drawbacks, like when you have combinations of decorators, things tend to get pretty complicated after a while, but there are some other patterns that you might implement to help solve these. So we'll get more into those later. And here they mention things like the adapter and visitor pattern. One of the great things about decorators is they're a composition rather than a top-down hierarchy. We'll talk a little more about that because that's kind of the main problem they solve, is getting rid of that massive hierarchy and rather just having an object that you can decorate up as needed. Another pattern we're going to talk about is the facade pattern. Essentially, it is pretty similar to the decorator pattern sometimes. Well, I guess it depends how you use it, but yeah, it says it can augment the facade pattern. So we'll probably see that more later. We just want to talk about its base usage here, but just keep that in mind for later. And being that there are drawbacks and different things you're doing with your code and stuff, there are alternatives. You don't always want to use a decorator. That's true for any of these patterns. You don't always want to use them just when they're appropriate. You can, instead of a decorator, you could use the adapter. Basically converts interfaces. We'll talk more about that later. The decorator's specialty is dynamically adding and removing responsibility. That way you can get exactly what you want. The facade, sort of like the adapter, it just redoes the interface in a more simplified way usually. A lot of people will do this when they're bringing in a library to their main project, is they'll put a facade over it, or a decorator, or an adapter. Depends what you need. Alright, let's stick with decorator though. Here's some UML class diagrams. You can kind of see the same thing here. There's the client, this is the interface it talks to, and there is what they call the concrete component. Concrete component is the one that you decorate up and add to the interface instantiation. So we'll do that in code, and of course we're going to do C++. Let's go ahead and just dive right down to their C++. And here they have a dynamic decorator, almost a deprecator. Oh geez. Shape, colored shape, and a main. And then they have another one for a web page, and then a static decorator with mix-in inheritance. So they've got 3 different examples here with the C++ code. All right, let's go ahead and run these and we'll walk through them and explain it. I could write my own code. I kind of want to do something for, like, you know, a game, like a character, and gear them up with a decorator because that tends to work pretty well. It also tends to work pretty well for custom making items and magic items, what properties you want them to have, things like that. There's a lot of uses of decorators that can be used in game type stuff too, but you know, that's just one angle. All right, well, let's dive into some coding, shall we? So we're just going to pop open Visual Studio Code. and open up our design patterns repo from GitHub. And I've already added a few things. I added a decorator folder, and in our design patterns folder, I've added to the CMake a new ads subdirectory for the decorator. And of course, this decorator also has a CMake that currently just adds a main, and maybe we could have it add a few other things too. Basically, the main is going to be our client end, and everything else is going to be kind of like a header only library. So let's just grab some of this code and test some of it out. So here's a dynamic decorator. We'll just grab from, well, let's grab all of this, everything but the main, and we're going to put this in a header. Let's get their main as well, just this. And of course, we've got to include shape so it knows what we're talking about. And let's see if the CMake auto-populated with that new add. It did not. So let's put it here, shape.h, to make sure it gets the code. It should anyway, just with the main, actually, but let's just make sure. All right, so let's walk through this from top to bottom. Okay, so this is the interface right here. It's just plain old shape. This destructor is virtual equals default. I'm not sure if that's required, but I'm pretty sure you want to have that for every interface in general, with your destructor on there. And we have a get name that returns a string. This is and it is const, so it's not going to modify anything, and it also equals 0, which means for C++ it is a purely interface class, or pure virtual as they call it. This means this object cannot be instantiated on its own. You can't make a shape object. It just won't allow you. You'll have a compiler error. Okay, now that we got that out of the way, but we still have shape to work with. So we're going to make another struct called circle, and it's going to inherit shape. So it implements shape. It essentially is implementing shape. We're going to add some new functionality to circle called resize. And this just takes in a factor and makes or resizes a circle with this radius factor. It essentially times the current radius by a factor. That's an odd resize. It's more like a grow, or I guess if you give it a decimal on the factor, it's going to shrink. This function doesn't make any sense, but it's beyond the point. Essentially, they're adding new functionality. Okay, and we have the getName function that we are overriding. And now this is actually implemented, so you can use it. It returns a string, a circle with the radius of whatever the radius is. We now have a circle that we could actually implement or instantiate. And you see they do that here. They implement a circle or instantiate a circle, and then they do something else. But before we get to that, let's dig through more of this code. So they make another struct called a colored shape, and this one inherits from shape. Now shape is pure virtual, right? So yeah, that's good. But circle, which you can see they're not implementing here, is not. So they are once again working with the interface class on this colored shape. And here's the constructor. You see they take a color, but they also take a shape. Boy, how can you take a shape if it's pure virtual? No one can actually instantiate a shape to give this colored shape, right? Untrue, because of the whole polymorphism factor. You can make a circle and say that is the shape. So you would pass in something that implements shape here, not the actual shape, and that's inheritance doing its thing. And then we just set those accordingly. And you can see in colored shape, we have an actual member function called it's a shape pointer. And since these are pointers to shapes, that's where these easily become flyweights, because, the pointer's not the actual object, it's pointing to the object. So whatever one you're filling out here, if you're reusing circle over and over and you want them to be the same, you could pass in that same pointer. But of course, if you modify one of them, it's going to modify all of them. So that's going to get a little tricky. But shape is public. So the thing about shape here is you can call all of shape's functions, but you won't be able to call circle functions necessarily so easily, because there's nothing in colored shape that implements the resize except for this potentially being cast to a circle. So that's basically it for this example. You can see they make a colored shape. They give it a reference to that circle, which is essentially a pointer to that circle, and they give it the string red, and then they just see out get name. So let's see if this actually runs correctly. I'm just going to use the terminal here, and let's see what we're working with. We already have a build folder, so we'll keep working with that. So let's open up terminal and go CMake. We're at the top level here of design patterns. Top level of the repo. CMake source of the top level one is where we are. So capital S dot. Now where do we want it to build? Dash capital B, and then we'll call that just the build folder. Put a little trailing slash there. That should be enough. Now we can call make. Well, let's just look at the folder here. We'll go down let's go into the build folder. Let's go into the design patterns folder, and we can see everything here. We're going to look at decorator, of course. So let's go into there, and there's a make file. So we want to just call make, and that builds our actual executable. Now, if you're on your root directory, the source is root directory, which is where we are now. You can still call make. You just have to do this -C and give it the directory. Build, what was it? Design patterns. Should help you if you hit tab and then decorator. There we go. So now it should run the make file in that folder, and there we go. So essentially you can do it either way. I've showed you both now. And now all we want to do is run it, and we can do it the same way. We don't necessarily need to do all the change directory is the point. So we can just go like this. I think we call this deco demo. Yep. And that's just how it was specified in the CMake, right here. Yeah, deco demo. Okay, and that should be good to run it. Let's give it a run. And we just immediately get an output, a circle of radius 10 with color red. So that code works. You can see where the fall off is. From colored shape, there's no way to call resize on the circle. So how do you fix that, right? Let's just try it here. Let's try a resize. Colored shape dot shape dot. Oh, the only option we have is get name. Now, since these are all structs and everything's public, it's a little weird. Usually you have stuff hidden and you make a cascade. So this is a very simple example. But you see here, we have no circle. But what we could do, and this is where things get a little awkward, but it's a hack. Maybe it'll give you some ideas, is you can dynamic cast. So we'll go auto. We'll call circle here. Standard, I think it's dynamic cast into a circle. But essentially, if this ends up being not null, you know that it's actually a circle. If it's not null, then we can assume that we can use it as a circle. And we would just have to call it like this, circle dot resize. Well, we don't want to see out the resize, but we could essentially call the resize circle resize, and we pass it whatever factor. I don't know, we'll just put a 10 in there. But you can see that it's not happy with this. Now, is there a reason? I think we need a certain header. Let's go ahead and look that up. So if you're not sure, you can always just do a copy on that keyword, go back to the Google, the Wikipedia, whatever you want to do, type in dynamic cast C++, look for the en.cpp reference, or maybe you're in a different language, that's fine, and let's just look at this dynamic cast and see maybe why we wouldn't be using it right. So you do call dynamic cast new type. It should say somewhere here which header it's from. Okay, it's not from any specific header. Apparently we don't need the standard on it. Me doing this whole standard thing is I'm assuming it's from the standard library, but it's not. Now it doesn't know what circle is. We want to cast to a circle pointer, I believe. Let's take a look at their example here. Oh, the pointer goes afterwards, like so. Let's go ahead and give it a run with this here command, where we just go into the directory and run the deco demo. And we see that it got the radius, got resized. Okay, so there's the example of casting to work with that example a little more. So naturally, you'd want all this casting and things hidden behind your actual classes would be the next step here. So you would want, like, for example, in your colored shape here, you would want some kind of thing that checks if it's a circle or what. You know, it gets more complicated. So let's check these other examples, see if we got anything more complicated. All right, let's look at this web page example, and let's grab all this code and not the main. And we'll go back into Visual Studio, add another file, call it webpage.h. Oops, I'm doing it at the wrong level. I hit escape. Let's go to the decorator, new file, and decorator, webpage.h. Paste all that code in, and let's look at their main and put that in there. Their examples are a little different. Okay, since we're using unique on this web page test, looks like we are going to need to include memory. Pretty standard there, just memory. And that should make this understand all of that stuff. And we also need to, of course, include web page, and that should straighten up the rest of the errors. All right, so let's look at this web page and consider a few things here, and we'll walk through it. So if we start at the top of this, we once again see there is an interface with a pure virtual display function and a virtual destructor equals default. Pretty standard there for a interface. And then we're going to implement this web page as a basic web page. We're going to keep a string of HTML as a member, and we're going to override the display to just say basic web page and not doing anything with the HTML. So maybe we'll just throw that in here as like a extra HTML. And we'll just leave it like that. I want to put the HTML actually in here. It should be blank by default, so there's no way to actually change it. But, you know, what's the point of having a memory if it doesn't do anything at all, you know? But maybe it's further down. All right, so we've instantiated it. There's a basic web page interface you can grab. So we see that there's another one. This one is also a web page. It's implementing web page. And this one's called Web Page Decorator, and it's going to take a unique pointer to a web page. And you see it's going to move that web page into here. Now move basically takes over the memory. This says now I now control the web page. So if you pass it here, this essentially controls the web page. And you'll see down here that this has a unique web page, a unique pointer. Now you can have pointers to these base classes, just like we could have a pointer to shape, and that's you know, unique pointers, still pointer. You can have a pointer to it, but you can't actually instantiate a web page. So this web page they pass in, it's not going to be the interface. They could pass in a basic web page. That'd be fine. And you can see here that we call the web pages display method. So it's going to call whichever one you pass in. So far our options appear to be basic web page. Now let's keep scrolling down. Let's see what else they make. They have an authenticated web page, which inherits from Web Page Decorator. So it's going to have all of this stuff in the private web page. And you can see they have a constructor here for authenticated web page that once again does take a web page. You got to have some legal web page in there, but now you could put in basic web page or web page decorator into there, any web page you want, and it's going to call web page decorator constructor and essentially set this this one here. So it's going to call this constructor, use this, set the web page, etc. But now we got a new method here that we haven't seen before. We got authenticate user method. And the display that we're once again overriding. Now this time when we override display, since that's what we're going to get when we call this, is we're gonna first authenticate user, which is weird. That's not what you want to do on display, because it's just going to say what? It makes no sense, but whatever. This is just for sake of example. But you see we call the display from the web page decorator, which is going to call this one, which is essentially going to call the web pages display. So the only thing it's going to do is it's now going to have this authentication in front of it essentially, but it's still going to use the display from the original web page, because this decorator has a web page. All right, let's look at another one. Here's authorized web page. Once again, uses our web page decorator, does the same thing on the constructor. It does essentially the same thing, but now it says authorization done. So this is where things get interesting, because you see they use this move, and this move literally takes it over. You can't be both an authenticated and an authorized at the same time. If you move it from one to the other, new things take over the memory. The authenticated page isn't going to know what you're talking about anymore. All right, so let's look at our main and see if we can make sense of what they're showing in the client end. First of all, they make a page, just a standard, you know, web page. This is the interface, the one that can't be instantiated, but they can if you instantiate it as the basic web page, because that one implements it. It's just a C++ thing of how you do interfaces. More on that if that's really confusing to people. I could make a video on that someday. It's not really a design pattern, it's just a C++ thing, but I don't think I've ever talked about it on my channel really too directly. It's mentioned all over the place in random videos. All right, and then we do something else. So we have this basic web page, but now we say, okay, well, let's make my page now an authenticated web page, and let's move in my current page, because you can. Now that's going to seem weird, but essentially the move is going to release, well, there's nothing to release here because you're essentially taking it over. You're saying this unique pointer, it was pointing to a basic web page. Well, let's make it an authorized web page, and let's pass in what it was before. And we do that again once it's authenticated apparently, and then we do a display at the end. So this final display should only display this one here, the authenticated. It should say authentication done is what we should essentially see. So let's go ahead and rebuild and hit play. Let's make sure CMake has this web page .h. That way it knows when things change. Let's open up the terminal, run we don't need to run CMake again. Well, actually we probably, I think it automatically did since we added something there. Let's just run the make file here and see if that's good enough. It should be. Run the executable, and there we go. We got authorization. We got authenticate. Now I didn't think if this would happen, because the only thing we're doing here is we're doing this move, a move, and then when we do this final display on the authenticated, what's happening there? Why is it going through and displaying ones from before? Okay, so if we look at the authorized, call the web pages decorated display. So this should be this web page. Oh, I see. So this is pretty interesting. We're essentially getting a cascade of effects, and that's probably what they intend here with this move things around. So when we call that final display, we're already authorized. So it calls this authorized user one, but it's also going to call this display here. Let's look at our terminal output again. I thought we would get this one first, but I guess with the way it is, oh, they're doing it backwards. So they're casting to this one last. Okay, so they're casting to the authenticated last. When we call this final display, we are an authenticated web page. So it should say this when we call display, and it should call whatever we're decorating. So we'll go back to whatever we passed in. Well, we passed in an authorized web page. So first it's going to call this. So we should get the authenticated message, and then it should call this one here. We should get the authorized done message second, which we do. And then we should get the base of whatever else moved in, which was essentially this decorator here, which is just going to call display on the web page, the basic HTML. So yeah, that seems to be working correctly, and you can see how you could cascade those effects. That's a great example. And you can see how if you continually move it in, you continually stack previous iterations may be a weird word, but previous versions of it. And thanks to the polymorphism, that is allowed here. And unique pointer is smart because we're not leaving old copies behind anywhere. We're just saying, hey, this is what it is now. Add a little functionality on. So pretty cool example there. Now there's one more on the Wikipedia. This is a static decorator with mix-in inheritance. And let's just take a look at it. We don't need to code it up, I don't think. But what you can see here basically is that there is no pure virtual. It just goes straight to circle here. They declare a circle, okay? There's no shape. And then they declare a struct that is a templated thing. So they name this colored shape, and they have a type name here, template type name, and struct. And then it inherits from whatever type. So whatever type you to say, that's what's going to get all the stuff from. So naturally they would do circle in this example. And you can see that the get name calls the type name's get name. So your type name needs to have that function or else this won't work. And as you can see, they do have a get name that matches that signature. And the only other thing they hold is a string color. All right, and here's the use of that static mix-in one. Essentially, they make a colored shape. They call the template a circle, give their variable name a red circle. This colored shape requires a string. They pass in the string red, and they see out its get name. Then they give it a resize. See, they can get to this resize function because of this templated type. So that's kind of interesting. We showed in the first example that you could dynamically cast it and check it that way, but that's kind of janky. That's hard to like tell the client to do that, you know? And if you have it buried in code, it gets real confusing with that kind of casting, but sometimes you got to do it. So with this kind of method, you don't need to worry about casting. They just need to make sure they pass in a valid struct that has a get name function essentially, since this is taking care of that. But yeah, that's another way to do your decorated patterns, and you could see how you could add in, well, more shapes. You could add in these structs kind of endlessly of whatever you want to have a different shape of. But yeah, I think that's going to be it. There's plenty more examples out there. I'll try to leave a few links. Mainly I'm just going to leave this Wikipedia link down below, but there are a lot of websites and other videos about this. So if you're still confused on it, consider checking them out. But in the meantime, yeah, just look at the code, study it a bit, it'll make sense. When you're coming up with your own thing that needs decorated, see if you can do this sort of thing. 20 likes, first day I'll stream some code. That's the deal. You know, link down below in the link tree thing. Yeah, I guess that's it for this video. I'll push this code, and hope you guys enjoy it. Hopefully it helps. Hopefully it hasn't been too long. I've definitely droned on a lot, I feel like, but I think we covered it as clearly as can be. Thanks for tuning in. I'll see you next time. Matt from Code Tech Tutorials, over and out. Peace. Circle called resize. Come on, speak correctly if you wouldn't. Resize. This default radius here is 10. That's what it's going to start out as. Helicopter in the background. Okay, so that's all well and good.